For this video, I'm going to cover topic 17, Learning Outcome 17.2b, to show you how environment factors can act as a stabilizing, disruptive, and directional forces of natural selection. So we're going to see how the environment can actually select the phenotype, therefore changes the allele frequency. I'm going to use this past year from May June 2018, paper 42, question 7, to show you how environment can act as a force of natural selection. So if you read this question, they actually gave you a table that shows as the year increases, the number of deer increases, but it's increasing at a slower rate from 1990 onwards and about to go into plateauing. So for this question, part B, it shows that the body mass of the red deer shows a wide variation, and this variation is favoring the medium mass. So you will see a normally distributed graph. But then when you look at the question wanted you to show that a selection pressure is acted on the red deer of a lower body mass. So it means that the selection pressure is acting against the low body mass. So I'm going to use a red arrow to show how the selection pressure is acting on the low body mass, and the allele frequency will most likely decrease. So as the pressure is acting on one extreme phenotype, the other extreme will be selected for. So I'm going to show you the selected against would be the ones at selective disadvantage. So how would the new graph look like? So as the high body mass is being favored, okay, let's show the new mean. So instead of the medium, now you will have the new mean moving towards the high body mass. So over time, the deer with a low body mass will be getting lower and lower, while the high body mass will be increasing. Therefore, the graph will be shifted more towards the right, and the graph will be normally distributed again. We wouldn't draw a graph that is skewed towards the right, but instead we will show a normally distributed graph, but the whole graph is moved towards the right hand side as the population will become normally distributed again. So this kind of force of natural selection will be known as directional selection, as one of the extreme is being selected for and the other extreme is being selected against. This is another example of question where it's from May June 2012, paper 42, question 1. So you will see that the question would mention where is the force acting on. So you have to learn how to read clues from the question. Where this question, they actually gave you the clue, which is quite straightforward, where they mention is a disruptive selection, where extreme phenotypes are most likely to survive because they have selective advantage. So they will reproduce and pass on the allele to the offspring. So here, let's label the x-axis, where we know that there's actually large and small. And we have another one which is intermediate. So I'll label this extreme as small. Here will be the intermediate. And the other end will be the large size seahorse. So how would you demonstrate the disruptive selection? So if the question did not show the original, you can always sketch the initial distribution, whereby the intermediate is supposedly the favorable one. So as selection pressure is acting on the intermediate, so now the small and large size is being more favored or selected for. So you will see a graph with two new peaks where the new peak is actually the same height as the initial graph. So basically, this is actually a type of natural selection. So how would you answer how the environment acts as a disruptive selection, where how the environment acts as a force resulting in disruptive selection? So like typical natural selection question, we will mention what is the pressure, who has selective advantage, who is at disadvantage, who survives, reproduce, and pass on the allele to offspring. So here, number one, we're going to start with the pressure is against the size. So we will talk about the pressure is on the size of the seahorse. So what happened here is, from the question, we know the clue is stated that the large one will mate with the large and the small will mate with the small one. So who is at a disadvantage here? There's no intermediate mate. So most likely if there is an intermediate seahorse, they don't have many choices and they don't really mate because they can't mate with the small one or they don't mate with the large one. So we will say that the intermediate are at selective disadvantage and few of them mate. So we can say that they are being selected against. So on the other hand, both extreme phenotypes are selected for. They survive and pass on the alleles to their offsprings. So if you can think of appropriate reason for why the intermediate is being selected against, or how the pressure is acting on the ones that is at disadvantage, and why is it that the other one is being favorable for, you will be awarded a mark. So in this case, what do you think can affect the size of the seahorse? Why is it that the intermediate one is at disadvantage? You can propose that most likely the intermediate ones are being predated, more likely, or their habitat is lost. So it's either you're small that you can find a habitat, or you're large that you can survive. So that's how you can actually get points for question related to natural selection. And the last one will be, how would you describe the selection where you maintain the same characteristics. So that means, who are you favoring? This is where you need to get the clue from the question, where a particular characteristic has been favored over time. This is known as stabilizing selection. And if you come across stabilizing selection, how would the graph looks like? Okay, let me guide you here. So if you're given a graph, on the y-axis, you'll be labeling allele frequency, and on the x-axis is usually the phenotype. So again, we're going to show a normally distributed curve. So what happens when the intermediate phenotype has always been favored? So here I will show that the intermediate is being favored. So your mean is still maintained the same, but over time the pressure will be acting against both extremes. So they'll be getting lesser, while the intermediate will start to increase. So the graph will be narrower and a higher peak. So this is how you show a stabilizing selection. So if you need more guidance on how to carry out calculation using Hardy-Weinberg and how to answer question about speciation, please contact me for group or private tuition. Thanks for watching.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.